Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Izzati binti Jeffrey and I'm from group Cloud Chaser 06. In this group, we have Adriana Huda, Hafiz Izzat, Adam Zehni, Farah Izzati, and the last one is Danish Naufal. So the contents of our presentation is about first, introduction, second, objective, third, scope and limitation, fourth, design, fifth, dimensions, sixth, materials, literary review, methodology, strength, weaknesses, image and video, and all. The last one, result and discussion, and the last one we have is conclusion. So I pass our presentation to the next one, which is Adam Zehni.
Assalamualaikum, my name is Muhammad Adam Zini and I will talk about our introduction for our rocket project. The CC06 air pressure rocket launcher compresses air to propel a lightweight rocket made from a soda bottle. When the air pressure inside the bottle is released through a small opening, it creates enough force to push the rockets upward, demonstrating basic principles of rocketry such as force, pressure, and aerodynamics. The aim of this project is to build a functional air pressure rocket launcher and investigate how two main variables, air pressure and launch angle, affect the rocket's performance, specifically its launch distance and maximum altitude. Through this experiment, the relationship between these variables and the rocket's flight behavior can be observed and understood more clearly. So I'll pass to the next presenter.
Assalamualaikum. My name is Hafiz Izzat. I want to talk about objective. First, to compare existing air-powered rocket and launcher design in order to identify their advantage. Second, to design and improve air-powered rocket and launcher based on the best feature from the comparison. Next, to determine readily available materials suitable for building a high-quality air-powered rocket and launcher. Next, to build the design air-powered rocket and launcher using this material. To test the performance of the air-powered rocket and launcher. Last, to analyze the launch result to determine how factors such as air pressure and launch angle influence launch distance and altitude. I pass to the next person.
Assalamualaikum, my name is Adriana Huda. I will talk about scope and limitations. This project focuses on designing, creating, and testing a simple air-powered rocket launcher using a 1.5-liter bottles and basic materials to understand how different air pressure affect launch performance. The design is straightforward, but it has limitation because of the material such as the plastic bottle that we use, and cardboard fins are low durability materials which reduce precision and consistency. As we know, in results, the rocket could bend or deform after repeated launches. Manual pumping can also produce uneven pressure, and weather conditions like wind and rain may affect the rocket stability and flight path. This observation help us understand both the strength and limitation of our design. Next, I'll pass to my friends.
Hi, I'm back, Farah. So the design, this is a few design choices that we have discussed, and for now on, we decide to choose design 3. So this is a design of our air rocket. So you can see the top view, and there's the measurement of all the compartment of the air rocket itself. So we use cardboard, and we also use manila card, plastic bottle for the fuselage of the rocket, and manila as the cone head for the rocket. Next, we have the design of the rocket launcher, which is we choose to use a bicycle pump as the core source to light up the launcher, and we also use for this launcher we mainly use PVC pipe and some other PVC pipe connector. And as you know, we also try to make the launcher unique. As you can see, there's very tall launcher, and from this we can make a better launcher to have a better result. So now from here we have materials, there's a few materials that we have been used, which is the main one that we use is a PVC pipe, and the next one is the PVC pipe connector, and the other one is most of the tool is we use duct tape for a better seal to avoid any leakage of air. And as you can see, we also use a bottle trap PVC, which is will contain the pressure inside the launcher before release. And we also use and the next one, you also use brass ball valve, which is to brass ball valve act as like a switch to turn off to turn on the pressure and release the pressure itself to the rocket. And other than that, for this launcher, we also use 1.5 liter water bottle as the base of the launcher. And as you can see, we need to paint some of the bottle and for some of the PVC to also avoid any leakage, and screw some of the parts, and also use the duct tape. And next, this is the dimension of the air rocket, which is, you can see there is a primary, all the measurement that has been right, which is the diameter, everything, wide and height also. And the last one is the dimension for the rocket launcher. As you can see, there is a wide 4 cm and height 39 cm.
Moving on to literature review. Air-powered bottle rockets demonstrate Newton's third law of motion, where pressurized air stored inside a plastic bottle creates potential energy that converts into thrust when released. As the compressed air rapidly escapes, it produces an equal and opposite force that propels the rocket upwards. The rocket's performance highlight that stability during flight is achieved through aerodynamic features such as fins, which help maintain a straight trajectory. Fins keep the rocket straight by reducing wobbling, or known as shaky movement, and helping it maintain a predictable flight path, as we know that poorly designed fins can reduce stability or cause damages. The rocket rises until the internal air pressure is exhausted, after which gravity becomes the dominant force, causing it to descend. For the next part, I'll pass it to my friend.
My name is Muhammad Ishnafar bin Rahman. I will talk about methodology of air-powered rocket. So for the body, gather 2 bottles of water, and then 1 bottle to make the fuselage, cut another 1 to make the random. For the fins, cut 3 triangular shapes. For the main fins, cut another 3 small triangular shapes for the upper fins. And third, a nose cone. Shape a piece of manila cut to form nose cone. Secure the manila cut using duct tape to the random section. And number 4, mount the fuselage bottle with appropriate position to attach the fin. Attach all the material into the rocket using hot glue gun or duct tape. And lastly, run for first launch test and record the result. Then run for second and third launch test and record the result. Compare all the results and identify problems, and do modification based on observation.
Hi, this is me, Farah again. So I will talk about methodology of rocket launcher, which is first connect all the PVC pipes and connector into one launcher. Attach the bottle trap and brass ball valve to the PVC pipe. build the rocket by joining two 1.5 bottles together, and the second one is fix the bottle firmly to the PVC T connector and seal all the joints together to avoid any leakage. The last one is the step 3, connect the rocket to the launcher and connect the bicycle pump to the valve, and make sure to close the ball valve and pump air into the bottle and you're ready to launch your rocket.
And for the strings, we have 6. And number 1 is strong PVC body, durable and not easily broken. Second, visible design, you can use it many times. And third, low cost made from cheap and easy to find material. And number 4, efficient pressure containment that help reducing stress concentration. And number 5, aerodynamic efficiency that minimize aerodynamic drag during flight. And lastly, design can be scaled to different size without fundamentally altering aerodynamic behavior.
So here I am. I'm Farah. So I'm gonna talk about the weaknesses of this rocket. First is about the pressure system. The uneven pressure distribution due to the dented bottle. As you can see at the cone of the rocket, there's a dented. Next, balancing. There's uneven mass of rocket, cause imbalance and affect its flight path. This can also affect the center of gravity. Okay, the third one is aerodynamic wrinkle. Tape or any rough surface increase resistance, which will also increase the drag. Okay, next, the fourth weaknesses is angle of a launcher. As you can see, we launch the rocket with an improper angle of launching, and this can cause stall or short distance only. Next is because of the sealing. Weak sealings or bad sealing will cause air leakage, so you will lose any connections and reduce pressure efficiency. And the last one is the material strengthness, which also can affect your performance. So there's a sum of the image, and this is the results and discussion that we got. Is, as you can see, as the pumping stroke increase, the launch velocity and distance both increase, showing a direct positive relationship between pump pressure and rocket performance. So what we can conclude from this project is, in conclusion, the Cloud Chaser 06 air rocket project is performed exceptionally well throughout its development. To achieve this kind of level of success, we require multiple designs of refinements to ensure that we can give an optimal performance and improve outcomes. So the project has been success for all of us. So thank you for listening, and goodbye.